set them.
Oh, got
Yeah.
it, got it, yep.
There you go.
Okay. Did I get notes, everybody? Did you guys get notes there? Okay, so everybody has notes right now. Brandon, did you find what you were looking for over there? Okay. All right, kids. Well, let's do this here today. So, kids, one of the things that we're going to have to make sure that we're able to do with all of the functions we've been looking at today is to perform what's known as function operations. Now, we've kind of done this to a fault back in Chapter 3. But the format, or the notation, if you will, is going to look a little different than what we dealt with back in Chapter 3 with some things. So what we're after today, guys, in college prep here, 4.5, our title is to perform function operations. Now, question here, what are we trying to figure out today? What are we trying to answer? How about a volunteer to read that for me here first today? Who wants that?
The essential question?
Yeah.
How can you use the graphs of two functions to sketch the graph of an arithmetic combination of two functions?
Okay, and that word, I'd probably pronounce it arithmetic.
Arithmetic.
Yep. So how do we use the graphs of two functions to sketch the graph of an arithmetic combination of two functions, okay? So what we're probably going to do, kids, today is we're going to look at some things in decimals. So I'm not going to necessarily tell you have to have decimals open because we'll model it up here on the board today. But decimals is certainly going to be something that you want to have handy to help you out with this, I think, all right? So in order to be able to answer that question up there, how do you take two graphs to create an arithmetic combination of two functions to create another graph? Our goal is to have to be able to add, subtract, multiply, and do what? Divide functions. Guys, there was a special kind of division we looked at last chapter. You remember what that was called? Synthetic. Everybody kind of remember the process for that? Okay. And I want to make sure we're good with that. But again, I don't think you're going to get into that too much because they're not really going to be dealing with values and coefficients as much as we are going to be looking at graphs. So goals, make sure you're adding, subtracting, multiplying, and dividing functions. I'll show you what this all means, okay? Vocab is kind of a review today. Domain. Domain covers which values on any function? The x values. So it's the x values. And I'm going to squeeze it all into two boxes of a function. Okay, it's the x values of a function, so we've known that. We've talked about that for a long time. So that's going to show up today. And then scientific notation. You guys have talked about scientific notation. Okay, anybody know what scientific notation is? Or can anybody provide me an example of a value written in scientific notation? Like 10, so it's a power of, or it's times the base of 10. So, yep. How about that first value? We always talk about it as a times 10 to the n, but a has to be smaller than 10. A has to be smaller than 10, but greater than or equal to 1. So an example would be like this. And maybe I make a note here. I'm going to say A is, it can equal 1, it just can't equal 10. I'm going to say A is between 1 and 10. So as an example, you might have, as an example of a value in scientific notation, maybe 3.7. Guys, does 3.7 fall in that window from 1 to 10? Okay, so that first value is a value between 1 and 10, and then maybe like times 10 to the 9th power, okay? What is this 9 right here telling me to do, kids, to my decimal point? 9 times to the right, and then if you had any placeholders to plug in for a value in standard form, you would just put in a bunch of zeros, exactly. What if my exponent was negative? What direction would you move your decimal then? Okay, so you guys have had exposure to this, and I think you kind of know what that means. So really the only vocab I'm concerned about today, understand what domain is. We've talked about that often. And then scientific notation, just a quick reminder of its form and maybe an example over here, okay? All right, let's get talking here, kids. Core concept today, the big idea behind everything. So this is kind of what we're going to be talking about as big ideas. And this is pretty important right here. pretty important stuff here for this core concept. Whoa. Maybe it's not important anymore if I just blank it out. Right, Pete? Okay. Whoops. This is the one I wanted right there. Okay, that's better. All right, here we go. Kids, core concept, operations of functions. It says let f and g be what? Any two functions. A new function that can be defined by performing any other of the four basic operations of f and g. First of all, we're going to talk operation, definition, and examples. So I'm going to go ahead here. I'm going to get you a couple of examples here to put up there. I think that when you see these, this is really going to make sense to you.
No.
Somebody up to here. Riley, maybe?
Maybe.
Okay, kids, here we go. Kids, the first one we have here is going to be the operation of division. And by definition, we say the following. We say that if you're ever dealing with an addition function where you have maybe like a function f plus a function g of x like this, this is just the following. It becomes f of x plus g of x. Okay, so let me get to my examples that I wanted to use here. Can you guys read that okay up there? Yeah? You can't do these kids. They're starting to act like sand.
Nothing wrong with that.
No, there isn't. I would think something's wrong with you if you didn't.
What's the bottom equation?
That says f of x plus g of x. Okay, if you see something written like this, f plus g in parentheses of x, that just means the following function, f of x plus g of x. So as an example right here, kids, I'm going to go ahead where the example box is up here. I'm going to zoom up on this a bit. Up here where the example box is, let's just do this. Let's let f of x equal 5x. And let's let g of x equal x plus 2. Okay, are you guys okay with that? So down here, kids, what would f plus g of x equal here? What would you write? Okay, so 5x plus x plus 2 is what Bell is suggesting. How many agree with that? Okay, yeah, you're simply just taking the two functions that are known up here. F of x is 5x, g of x is simply x plus 2. I want to add them together, okay? Now, is there going to become a situation where, ooh, maybe we should simplify some stuff in this? Any terms you could combine, in other words? 5x and 1x. So what do you want to call this, Xavier?
6x plus 2.
Very good. There it is. So f plus g of x is simply 6x plus 2. Very good. Right? 6x plus 2. All right, guys, so let's talk right here. That was addition. We were good on that. If I get down here to subtraction, anybody maybe have a rule for what subtraction of f minus g of x would look like? Anybody have a guess? F of x minus, I don't like that. F of x minus g of x. Okay? So let's talk up here. What would f minus g of x equal up here, kids? Well, what is f of x, kids? Okay. And I want you to be really careful on this here, kids. We're going to say 5x is f of x to start with, but what are we subtracting from that? So we're subtracting x. Okay, make sure you put this x plus 2. Anytime we deal with subtraction, always put that second part right behind the subtraction sign. Always put the whole function in what? In fact, if you want to put each parenthesis or each function individually in parentheses, that would be good. Okay? So kids, really, what's this minus sign going to do to everything over here? Okay, so this really becomes 5x minus what? Okay, so what's 5x minus 1x going to get you? And then how about my plus 2? What's that going to become? Minus 2. 4x minus 2 is what I have there. You guys okay with that? Yep. Go up there and look my top right drawer over there. Okay. All right, kids, multiplication then. Here we go, multiplication rules. Okay, so multiplication is going to be f times g of x is simply going to be f of x times what, kids? So if I'm being honest with myself about this over here, if I want the product of these two functions up here, f times, you find one? Hang on. No. Did you go top right? Just need a eraser or a pencil? Okay. This is just going to be what times what, kids? 5x times. Yep. Okay, so let's simplify this, or in other words, distribute. What's 5x times x going to get you? Yep, 5x squared plus what? Okay. And then lastly here, kids, we're going to have some division down here, which simply says you're going to have f over g, like so, of x. This is simply f of x divided by what, kids? Okay, so f over g of x here would equal the following. What is my f function again? Over what? Okay, and we can just leave it like that, and we'll look at that stuff here in a little bit, okay? Forgot to circle the third example, 5x squared plus 10x. Guys, really, you're just taking the two functions and you're performing the indicated operation, whether that operation is addition, subtraction, multiplication, or division. Pretty simple, but maybe I ask the question, instead of just writing it out, are there going to be situations where you need to combine terms or simplify? Page 1, any questions on the notes? Let's jump into some examples and see if we can't kind of figure this out today. You guys are going to help me through this. So on the top of page 2 here, first thing it says to do is what, kids? Add what? Okay, so add two functions here. So I'm going to go ahead and get decimals open because I know that we're going to need this. Pandora, how to make friends. Ooh. Maybe Tall Skinny can make some friends today. Let me get in here, kids. All right. Let's go back to notes here. So in the notes, example 1, take a second and read that, if you will. All right, example 1 says we're going to do what with the functions, kids? We're going to add. So let f of x be what? 5 root x. And g of x is negative root x. It says find f plus g of x and then do what? State the domain, then evaluate the sum when. Okay, help me out, kids. First of all, we're going to have f plus g of x here. That's going to equal what plus what, kids? What's my f function? What's listed first for f? 5 root x plus negative 8 root x. Is that right? So we're in a situation here, kids, where we have like radicals, don't we? You have 5 root x's and add negative 8 root x. What does that leave you with? Negative 3 root x. Okay, so there's our solution right there. There's our solution. Gosh dang it. Okay. Then the next thing they ask you to state is your what? Domain. A couple different ways I can look at this. First of all, kids, we're dealing with square root of what? Dealing with square root of x. And when we're dealing with square roots here, kids, what numbers do we not like as a radicand? What numbers don't you really want to be taking the square roots of? What kind of numbers don't you want to take square roots of? Negative, because they leave you with an imaginary value, okay? So the domain on this, all x values should either be 0 or what? Yeah, it should be 0 or positive. So we think the domain is going to be x is greater than or equal to 0. Haley, did I miss something? Did I miss a fun? What I missed, Tessa? Help me out.
I said negative 3 times.
Oh, you did? I'm telling you, I'm losing my hearing. You've got to speak up for me, kid. Well, thank you, Haley. No, hang on. Thank you. Did you get that back 3 times?
Yeah.
Okay. We think the domain is x is greater than or equal to 0, but here's where I would encourage you to say, okay, I've come up with a function here. Let's just type that in. What do we get for a function, kids?
X is greater than
Negative
3
3 root.
root x, yep. So I'm going to just type this in here. I'm going to go negative 3 roots x here. Here's our function, kids. Guys, if you look at the domain of this right here, it looks like it starts at 0, 0, and then it continues to move what direction? To the right. So it looks like the domain in this is all x values greater than or equal to what here, kids? 0. So does it confirm what we thought there when I look at that graphically? You bet. Okay, you bet. All right, and then the last thing here, kids. Last thing, it says to evaluate the sum when what? X equals 16. Basically, they're saying evaluate f plus g of, what are we plugging in for x, kids? Okay, so this is simply going to equal negative 3 times the square root of what, kids? Well, help me out, kids. We're going to look at that square root of 16 as what value? 4. We have to look at it as 4 because we just said the domain value has to be greater than or equal to 0 here. So I throw that in. It's bigger than 0. We've got 4. What's 4 times negative 3? So here's the deal. One of the points that should show up on my graph, what did we input for this function, kids? What did we get for an output? With a little bit of luck, that point 16 comma negative 12 should be on the graph, shouldn't it? So let's take a look. Let's see if that's true. I'm going to follow this, and I'm going to follow this down to 16. Does it look like 16 negative 12 is going to be our value? Oh, I saw it. Did you see it?
Yeah.
right there.
Well, you get it though, right?
Yeah.
Okay, so 16 negative 12. What do you guys think about this? Manageable? Okay, here's what I want you guys to do then. I want you to try example 2 on your own. Okay, now remember, it's subtracting. So what should you probably do with these functions? Put them both in parentheses. I want you guys to try number 2 on your own. Okay, when you have number 2 done, I want you to check with your neighbor. If you agree, awesome. If you disagree, I'd like you to talk about why you disagree there. Okay? Sure can. You guys maybe check my work once you have this, all right? Okay, I'm ready to talk. How many need more time? Give me a show of hands. How many agree with maybe what I put up there? Okay, again, we got to be careful on this right here. When I put a minus sign in here, after g of x, what's this minus sign do to everything in g of x to the right here? Switches everything for us, right? How many agree with my f minus g of x as negative x to the third plus 9x squared minus 14x plus 13? Would you agree with that? Okay. How many agree that my domain is all reals? Cubic function, okay? And I can't put in for x. If I wasn't sure, where could I go, kids? What was the function we came up with? Somebody read that to me. It was negative x to the what? Negative x to the third. Help me. Plus 9x squared. I'm listening. Cubic functions. We know things about cubic functions. We know enough to know that the domain of those is all real numbers. Now, if I wanted to know what x was when we got to negative 1, I could have followed this down. Ooh, I've got it. When I input negative 1, what's my output? 37. That's one way I could have gotten that. Or, all I did was plug negative 1 in everywhere where there's an x, and that all turned out to be 37 for me, okay? Kids, in a nutshell, I went through that pretty quickly, but how many are on board with that right now? Anything we need to discuss there? Something that's up there you're not sure about? How many of you say, yeah, I've got this? Awesome. Let's move. Yeah, absolutely. Okay, example 3, kids, multiplying two functions. I love this right here. This is pretty simple. What's your function f of x, kids? X to the what? X to the third. That's right, it is. So this is x to the third. What's g of x equal to? Okay. Find F times what? Okay, now I could do this a couple different ways, kids. First of all, f times g of x right here could be the following. Could equal x to the third times what, kids? I could leave that just like that if I want to. Okay, or we know enough about an index here on roots. What index is really out here? Isn't this really x to the 1/2 power right here? We could say that this is really equal to x to the third times x to the 1/2, couldn't we? Agree with that? What's 3 plus a half? 3 1/2. We might say, you know what, hey, this is x to the 3 1/2 power. But I don't like having a mixed number up here. How would I change this 3 1/2 into an improper fraction, kids? Or maybe the better question is, what's the improper fraction for a mixed value 3 1/2? 7/2. So I could really say that this is x to what power, kids? X to the 7/2. That's what we're looking at right there. Okay. All right. Let's look at a graph of this for my domain then. Oops. This is probably what I would say right here for my function, x to the 7/2. Okay, let's talk domain. I'm going to put this in as x to the what power, kids? You have to be careful on this one. You're going to raise it x to the, make sure you put parentheses up there, 7 divided by what, kids? Let me zoom home on this for you. There's your function. Looks like it starts right here at what, kids? So what do you want to say about your domain? All real numbers greater than or equal to 0. Yep. So we're going to have starts at 0, moves to the right. And the reason that holds is because I have a square root right here, don't I? And what kind of numbers do you want in here for square roots? Only positives. Okay, so the domain, x values greater than or equal to 0. Now we have to evaluate f of g of 4. No problem. This becomes 4 to the 7/2 power. Okay, anybody have a calculator? 128. So with a little bit of luck, kids, which point would be on that graph? What comma what? 4 comma 128. Let me check. Tell me if you see it. Did you see it? Are we right? Bet we're right. How you feeling about this? Pretty easy, isn't it? Give me a show of hands here. Give me some sort of sign if you're alive. Feeling pretty good about it? Okay. Let's move on. It's another example. We've covered the first 3 operations. What do you think the last operation is that we need to look at? Division. Not too bad here. Let f of x equal what? 4x and g of x equal to what? X and 2 there. This should say f divided by g right here, kids. Or f over g, if you will. Okay, so here we go. F over g of x here, kids. Going to equal what over what? 4x over what? Squeeze that in there. I don't like the way I wrote that. Kids like bases in x. Isn't this really x to the first up here? What's 1 minus 2/3 then? Okay, so I could choose to write this as 4 times x to the 1/3. Or maybe some of you want to call it maybe 4 times which root of x? 1/3 power is the same as which root? Okay, so are you okay with either one of these functions up here? Let's see a domain here. Let's look at a domain. I have 4x to the 1/3. Is that what we had, kids? Is that right? What do you think about your domain for that cube root function? All reals. You guys have this. You guys are so good at this. So the domain on this domain all reals, you say? What's that you say, Sam?
What?
Then we have to evaluate f of g of what do they want that to be? X is what value? 27. Well, kids, it's basically saying 4 times the cube root of what? What the heck's the cube root of 27? 3. What's 4 times 3? 12 is your answer, kids. Okay, I'm going to cheat this next one a little bit. I like to use what is my technology? Desmos. Okay, performing function operations using technology. I'm just going to simply tell you, put them in as is. Make sure you put everything in what, though, probably? Parentheses. It says, let f of x equal the square root of x, and g of x is root 20 minus x squared. Use a graphing calculator to evaluate f plus g, f minus g, f times g, when x is equal to what all the time? Okay. I want some help with this here. So I'm going to show you, we'll do f plus g together, and then you guys are going to tell me what the other one is, all right? So I'm going to divide this up like so. Oh, that's terrible. Let's do f plus g right here. You ready, kids? So what do I have to type into decimals? F plus g, what do I have to type in? Okay, I'm going to put square root of x in there first. And get outside of parentheses for that first one. Plus
The square root of 20 minus x.
okay, there it is. There it is. We have to evaluate this one. X is what? I'm going to do my best to scroll onto this a little bit. Now I could plug 3 in. What do I get? 5.049. You guys okay with that? There's the graph of it. Okay, when x is 3, I get 5.049. So I come over here and I'm going to say f plus g of 3 was equal to what value? Well, 5.049. Okay. I need a volunteer to do f minus g in decimals for me. Who would do f minus g? Anybody want to punch that in? I guess I could go in and just change the plus sign to a minus. Is that okay right now, guys? Can we do that together? All right, let me go in here. Change the plus sign to what, kids? Okay, there's the graph, and we're evaluating again when x is what value?
3.
So right in about here. Try to get there. Can you guys read that quick?
-1.5.
-1.585. Does everybody get what I'm doing here? Okay, negative 1.585. When x is 3, I want to come over here to x is 3 about, hover above here. Again, I could plug 3 into both functions and evaluate, or I could just graph them like this. When my input's 3, when I combine these, my output's negative 1.585. So f minus g of 3, negative 1.585. What's the last one we have to evaluate? F times g of x, is that right, kids? So f times g of 3. I'll just go in there and change that to a times. Are you okay with that, kids? So change this to what? And we're evaluating at what value again? So right in here about. If you see it, remember it. Got it? Got it? Okay, I can't remember. 5.745? Okay, last example, and then I'm going to tell you, kids, I know we're running short on time here, but I will send out an online here during win time, so maybe be looking for that. Don't forget, 4.4 online, what time today is that due? 6 o'clock, okay. Guys, last one right here. It just says from 2000 to 2010, the population in thousands of cities, M and N, can be modeled by M of t. You can read that polynomial function. And N of t, you can read that polynomial function where t is the number of years since what? 2000. Okay? Want you to think about this. We're going to ask some questions about this tomorrow. We're going to ask some questions here about this tomorrow, but I just want you to have this in mind. We'll start with this first thing tomorrow. But any questions about this? Again, give me a show of hands of the people in here that feel pretty comfortable about what we discussed today. Okay, feeling okay with this? All right, very good. So be looking for that online coming out here during win time. Did you guys all select your win?